Hi everyone, how are we doing? Hope we're good. Welcome to a slightly different video to the usual kind. This video, unlike my other ones, which are predominantly aimed at learners and students, this one's aimed at both students and lecturers or people who are producing resources in electrical engineering. So this video is designed to introduce you to a little set of calculators that I've been working on in my spare time over the last few weeks to allow the user to calculate solutions to single-phase RLC questions and three-phase RLC questions as well. In this video, I'm just going to introduce both calculators and how to use them. And in another video, I'm going to go into a bit more detail and talk about the way I programmed Excel, the formulas I've used, my thinking behind the sheets and how I want them to be used, hopefully, and also where I plan to take them in the future. All right, so to use the single phase RLC question, obviously make sure you're on the single phase RLC tab down the bottom here. And if you have a question you're trying to work through and you're maybe not sure about, perhaps the solutions in the book don't include a step-by-step solution, your lecturer maybe hasn't had the time or the chance to give you the full work solution to some of the problems that you're working on, then this can be a great resource, because what you can do is you can plug in the values up here in the top row 5, and then the spreadsheet will automatically work out all the solutions for you and give you them for you. So let's go ahead and do that. Going into the cell and changing it. Now bear in mind that whatever voltage you put in the voltage cell here is the RMS root mean squared value. Frequency, let's just change that to 50. And resistance and inductance capacitance I'm going to leave as they are. However, what we could do is we could change them the same way. And if we wanted to enter the value as it perhaps appears in the question, so for example, maybe it's 100 kilo ohms, then we can come down here and select the K. And you can see here that automatically translates that into 100 kilo ohms. For the purpose of the video, I'm just going to leave that in its standard form. So it's 100 and run through the rest of the values here. Okay, then that's it. You don't need to do anything else. The calculations are all done for you, which is fantastic. So we can see here that the reactances are automatically calculated. Our inductive reactance is calculated for us. Our capacitive reactance and our overall reactance are calculated. Formulas that are used are here on the right-hand side, along with the substitutions. So if you've made a mistake somewhere, you can go and compare your substitutions with the spreadsheet here to see where you've maybe gone wrong. Then the impedance is calculated. You have your magnitude of impedance. And if you're a bit further advanced in your studies as well, you've got the complex representations in terms of the rectangular representation here and the polar representation of your impedance there as well. After that, we have our supply current being worked out for us, which is nice and handy. Again, this could do with a bit of updating, but you have the rectangular version of it here, and you have the polar version of the current there as well. And you also have the formula and the substitution just to compare with your own workings. Then we move on to the phase angle and power factor, fairly self-explanatory. You have your phase shift, and you have the nature of the phase shift, whether it's leading or lagging. And finally, the power factor for the circuit. And here's the formula over there as well. And then finally, in the last step, you have the voltages over each of the components, the voltage over the resistance, over the inductor, over the capacitor. And again, just for ease of reference, to have all the voltages together, the voltage over, or the supply voltage as well. One of the things about the spreadsheet that I'm quite pleased with in terms of how it's come out are the fact that it plots the phasor diagram automatically, and also the sine waves, just so you can visualize the phase shift between the voltage and current at the same time. In terms of the phasor diagrams, you'll see two, and over time I might update this and probably get rid of the unscaled one since it will be less useful. But I'm leaving it here just now, just to make sure you're aware that the values you're seeing in the scaled phasor diagram are not have been multiplied basically. And so what I've done here is with the current, I multiply the current up so that it increases its size, because otherwise, when compared to the voltage, if you just plot the raw values, then it ends up as just a little blue dot in the middle there. Whereas if you multiply it up, it actually kind of represents the current a little bit better. So I'm very pleased with how that turns out. There is a few issues with that, just as a health warning, I suppose. The first is that it doesn't give you the exact scaling correctly, because sometimes it changes depending on the values. And really, to get it to scale right, you would actually have to have these, have the units here square, have the actual cubes or rectangles square on the graph. That means it would actually scale each of the values correctly. So just be careful with that. What I'm saying is, I think when I give this out to students, is that the diagram here should be used as a reference, a sort of guide to what yours should roughly look like, not exactly, okay? It should roughly look like this. On that note, if anybody does know in the comments how I can make it so that when the table updates that the axes remain linear to one another, so that this is 50 and this is 50, up and down and left and right, then please let me know in the comments. That would be absolutely smashing. I've not figured that out yet myself. And that'll definitely be something I'll be working on as I improve the spreadsheet as a whole. The other thing I'm quite pleased with, as I mentioned before, is the two sine waves. So this is just a quick illustration to show you the voltage versus the current. Again, the current has been scaled differently, so no, it's not 75 amps. It's just the purpose of it is to show you the phase shift between the voltage and the current. The reason it's magnified or amplified, sorry, is just so that it appears on the screen. Otherwise, compared to the voltage, it just looks like a flat line. One thing I would be quite interested, again, I couldn't find a solution myself, is to have two separate scales on the voltages here, on the scatter graph, if you like. What I would like ideally is a scale on the left showing the voltage and a scale on the right showing the current. So that means I wouldn't have to really multiply the values as such. I could just have two separate scales, and it would look, I think, a lot nicer as well, be a bit more useful information. Okay, so hey guys, and welcome to the three-phase AC calculator on the other sheet down here. Now, to use this, basically you need to put a few options, select a few options up here first. So first of all, you need to select whether it's a star or delta. You need to tell if it's balanced or unbalanced. Select the phase rotation. Usually it's normally going to be left as ABC, but if you get a really unusual question where maybe the phase rotation was reversed for whatever reason, you can choose that here as well. You have to start by selecting the line voltage. In the future, I'll maybe change this so that you can select the phase voltage if you want. But for right now, it's based on the RMS line voltage. At the moment, I've got it set to 415. For the supply frequency, again, you can punch that there into 60 or 50 or whatever you like. If we're dealing with an unbalanced system, unbalanced star system, then there is the option to decide whether or not there is a neutral or not. Basically, this represents the neutral cable. Obviously, if it's a balanced system, then the neutral doesn't really matter. If it's unbalanced, then if there's a neutral, you'll work out the neutral current. If there's no neutral cable, then it will use Millman's theorem to automatically calculate your individual phase currents and line currents from that. But we're just going to keep it nice and simple and say it's balanced. There is a neutral, and we can select our reference voltage. You can either have line or phase, and then you can select which phase you want to be the reference. This just affects the angle, the phase angle, and which of the phases you take as the reference for the phasor diagram, and I say the phase shift or the phase angle on in the calculations. Then you need to go in here and enter the values for each of your phases. At the moment, it's pretty straightforward / simple, in that you can enter the resistance, the inductance, and capacitance. There are a few little bugs in the system. I need to go through and put some error handling in. So if you put a certain values in and you maybe get 0, then it'll end up, a 0 for your inductance, capacitance, reactance. Sometimes that'll end up creating some division errors in the rest of the table, but I'll update that at some point. If you're doing a balanced system, you only need to enter in the values in the top row here, these 3 cells here. It doesn't take into account these cells when the system's balanced. That's why I kind of grey it out. If we change it to unbalanced, then you can actually go ahead and these values then get taken into account. If you're dealing with a balanced system, the only cells you need to really be changing are these ones here, and it basically does the calculations based off of those. Once you've entered all that information, then the calculations are all done automatically for you. Works out the reactances of each phase, so you've got your inductive reactance, capacitive reactance, and overall reactance. impedance of each phase. In this case, they're all the same because it's balanced. If I was to change that to unbalanced just for a moment, you can see now it works out all the individual impedances for all three phases. Over here is the admittance. You don't need that if it's balanced, and that only really comes into account when there's an unbalanced star connected system with no neutral, and this is where we then go on to calculate the neutral voltage in our unbalanced system, so we can start doing Millman's theorem, but we don't really need that when it's balanced. Back to a balanced system. The spreadsheet then calculates out your line voltage, phase voltage, line current, and then your phase current in both polar and rectangular format. Your powers, so power of each phase, so phase A to neutral, B to neutral, C to neutral, three phases added up together gives you your total power consumed, true power consumed. This gives you your total reactive power and then your total apparent power as well. Then we can kind of ignore the component section here, and we get to the nice part of the diagram, or nice part of the spreadsheet, where we have the three-phase phasor diagram automatically created, and this will automatically update based on what you've selected above. So if we were to go up and change some of these, you can see that if we change that, say, to delta, then you don't really need to change anything. We can say even unbalanced delta. Say you don't need to change anything. Other than that, all the calculations now work themselves out, and we can see that's plotted on the spreadsheet, on the scatter graph down here, and you can see it automatically updates and changes itself. So here now it's plotting the two currents, so you get your phase current and line current, and then you've got your phase and line voltages, which are the same in delta. If we go up here and change that to star, now it's plotting line and phase currents, which are the same, so they overlap each other, but you've got your line currents, sorry, and your phase currents as well. In terms of things to do next, you know, obviously I think the priority would be to change the user interface here. There's a lot of calculations going, and I'll probably work away at that over the next couple of weeks and months when I get some free time, just in order to tidy it all up a little bit, because it is a bit too much information on the screen. But that said, I didn't really want to sit on this for another couple of weeks. I thought I might as well just get it out. People can use it if they want, and as and when I get the chance to update and tidy it, I'll just make some small steps and progress on it. As I say, there are a few little errors that can pop up here and there. I need to put some error handling in so that if there's a zero appears in here, for example, if I put the capacitance as 0, this tends to mess things up a wee bit. Yeah, you can see it doesn't like having a 0 in the formula. That's a relatively easy fix. I just need to go in and throw in a little conditional in there. If there's a 0, or if it becomes divide by 0, then it just outputs a value of 0, and then that would fix a lot of those problems. Just not had a chance to do it yet. Other improvements, I need to add some scaling to the phasor diagram, because as you can see, it doesn't really scale correctly for the currents, so it's not really doing a good job at displaying them. That is absolutely my next priority, is to get that fixed. Just like with the single phase and RLC circuit as well, the phasor diagrams, I'm not really sure how to set it up so that when the scales or when the diagram displays, I would really like it if these boxes could be the same size, because if you look closely, you'll notice the distance between 0 and 100 on the vertical axis is not the same as 0 to 100 on the horizontal axis. Ideally, that should be square in terms of the physical distance should be the same, because basically it means you need to come in here and adjust it a little bit to get what should look like the actual diagram. And that's important because that will affect things like the actual angle, the physical angle it's in here. But that's a problem I'm working on. As I said before, if anyone knows a solution to that, please let me know in the comments below. I'd love to be able to have it so that it just automatically scales correctly in both dimensions. Also, just like you know, again, as I mentioned before, I'm going to look at putting a button in here somewhere that basically allows you to click it and export it directly to a Word template that will create the questions and solutions for you. And then the last one, which I alluded to earlier, is definitely format this thing for neatness. At the moment, it's not looking very tidy. I could hide a lot of these things. A lot of these values either could be hidden entirely or just grayed out. They're kind of well, visible because I've obviously been working on the spreadsheet and I've been needing to see the values. But now that I've sort of got it to a relatively good working position, I could go ahead and start graying these out. But that being said, there's still a lot more work I could do in terms of making it a much neater presentation, easier to read, especially if you're not really long into working with complex numbers, if you're a student, or if you've just sort of started onto your three-phase experience, then it'd be nice if it was laid out a little bit better. But that's it from me. I hope you enjoy the spreadsheet. I hope you find it useful at the very least. Maybe it helps you with your studies. If you do find it useful, please let me know in the comments below. If you can think of any additional features that should definitely be added into it, then I would absolutely love to hear the recommendations in the comments, and I'll certainly try my best to incorporate them as best I can. And one last thing I suppose I should say is I am also looking at including, just like with a single phase RLC, I'll be looking at including a little button that allows you to export all the values to the Falstad simulation website, and it basically just creates the circuit equivalent there for you, so you can actually see it live in simulation as well. Anyway guys, thank you very much for watching the video. I hope you find the spreadsheet useful in your studies or in writing some of the questions. If you do, please let me know in the comments below, and if there's anything you think I should add to the spreadsheet, I'd love to hear what you think on that as well. Don't forget to like and subscribe the video, and I will catch you in the next one.